Hey, Math 20-1s. We're going to start trig today. We're going to look at angles in standard position. First definition of many. An angle is in standard position when its initial arm is on the x-axis. And that would be the positive x-axis. And the angle's vertex is at the origin. All right. Point P, X, Y is a point on the terminal arm of an angle in standard position. So here's an example. That's called the terminal arm. Here's our initial arm on the positive x-axis. So we would say angle theta is in standard position because the vertex is at the origin. So the point PXY is on the terminal arm. There's our initial arm. There's our terminal arm of the angle in standard position. So let's sketch a few of these in standard position. A couple things we should remember. This is quadrant 1. This is quadrant 2. Quadrant 3 of a coordinate plane, and quadrant 4. Also, we should remember that positive angles go in a counterclockwise direction. So an angle of 70 degrees will always start at the initial arm, positive x-axis, and it will go in a counterclockwise direction and be positive. And if I go 70 degrees, my terminal arm will show up right there. 150 degree angle, again starting at the positive x-axis and going in a counterclockwise direction, 150 degrees. The terminal arm should end up in quadrant 2. 150 degrees, quadrant 2, angle in standard position. 245 degree angle, again we start on our positive x-axis. We go in a counterclockwise direction for 245 degrees. So there's 90, there's 180. The next quadrant starts at 270, so 245 won't go all that far. It'll end up with a terminal arm in quadrant 3. There's our 245 degree angle. 330 degree angle, again, positive angle, starts on the positive x-axis, goes in a counterclockwise direction, 90, 180, 270. Well, 360 is a full rotation, so we're not going to make it all the way back to a full rotation. So a 330 degree angle in standard position would have a terminal arm in quadrant 4. Negative angles start on the positive x-axis and they go in a clockwise direction. So a negative 165 degree angle, well, here's negative 90. Negative 180 would be here, but 165 negative isn't that far, so the terminal arm should end up in quadrant 3. And a negative 220 degree angle, again, starts positive x-axis, negative angle, so we're going to go in a clockwise direction. 220 degrees, we'll have a terminal arm finishing in quadrant 2. So those are angles in standard position. Alright, our next definition. Angles which have the same terminal arm are called coterminal angles. So example 1, calculate two angles which are coterminal to each angle below. Make one of these angles positive and one of these angles negative. Now you won't have room to draw this in your notes, but I'm going to draw it here as a start and then we'll erase it. But if I draw an angle 150 degrees in standard position, positive x-axis, I go 90, there's about 150 degrees. That's my 150 degree angle in standard position. There's angle theta. I want to make a coterminal angle to that. That means it's got the same terminal arm. That arm is going to be the same for two angles, one positive, one negative. So if I go in a clockwise direction, there's 150. I do another full rotation and I'll end up at that angle again. So it's going to be 150 plus a full rotation, which is 360 degrees. So 150 plus 360, one coterminal angle should be 510 degrees. I could go in a negative direction. So this is my coterminal arm. If I go in this direction, there's my terminal arm. So I went in this direction, which would be 360, take away 150. So 360 less 150, I'd have a negative angle of 210 degrees. So this angle's negative 210. So that's how we make coterminal angles. They must have the same terminal arm. So 510 and negative 210. So for a negative 70 degree angle, if we look what we did with the 150, we added 360 to this. So 360 plus negative 70 is 290. And then we're going to subtract 360 from that. So negative 70 minus 360 is 430. So we're adding a rotation and subtracting a rotation. That'll give us the same terminal arm. 305 degree angle, again, if you want to see a diagram, a 305 degree angle has its terminal arm in quadrant 90, 180, 270. There's 305. So if I add another full rotation to this, add another 360 to 305, I'm going to get one. And if I subtract from 360, I'm going to get the other one. So 305 plus 360 is 365. 305 minus 360 is a negative 55. All right. Note, if angle theta is any angle, then all angles coterminal to theta are represented by this equation. Theta plus n times 360, where n is an element of the integers. So all this equation is saying is we're going to add or subtract values of 360. Rotations positive and rotations negative. All right, so n is an integer. That means it can be a positive or negative whole number. I can add or subtract rotations 1, 2, 3. I could do 4 rotations and come up with a coterminal angle. All right. So for example, write an expression for the family of angles that are coterminal to each of the following. So I've got a negative 40 degree angle. All I do is plug that into this equation for theta. So negative 40 plus n times 360, where n is an element of the integers. And that is all the positive or the coterminal angles to negative 40 degrees. For part B, same idea. Plug in your angle theta, 280 plus n times 360. And again, n must be an element of the integers. So all we're saying is n can be positive 1, so I'm going to add a rotation. N can be negative 1, I'm going to subtract a rotation. N can be positive 2, I'm going to add 2 rotations or subtract 2 rotations. And I could do that on and on for as many integers as I want. All right, next definition. For any angle in standard position, its reference angle is the acute angle between its terminal arm and the x-axis. Acute angles we know are between 0 and 90. So if we have an angle of 120 degrees, the reference angle is, let's have a look. If I draw a 120 degree angle in standard position, terminal arm angle in quadrant 2, there's a 100 degree angle in standard position. The reference angle is the acute angle between the x-axis and the terminal arm. So that angle should be 180 minus 120, or 60 degrees. All right. For each of the following, sketch the angle of standard position, find and label the reference angle. Here we go, 80 degrees. In standard position, terminal arm should be in quadrant 1. There it is. The reference angle from the x-axis to that terminal arm is still 80 degrees. So the reference angle is also 80 degrees. B, 147 degree angle. In standard position, the terminal arm is in quadrant 2. There's a 147 degree angle. The reference angle is right here, 180 less 147. That reference angle is 33 degrees. Example C, negative 135 degree angle. In standard position, this angle has its terminal arm in quadrant 3. We go negative, start the positive x-axis and go in clockwise direction. There's our negative 135 degree angle in standard position. The reference angle again is from the x-axis to the terminal arm. So again, that's going to be 180 and 135. The difference there is 45 degrees. All right. Example D. A 421 degree angle. Well, if I want to draw that in standard position, that's going to be one full rotation, and the terminal arm will end up in quadrant 1. So one full rotation, and then back in quadrant 1. So here's our reference angle from the x-axis to the terminal arm. How do I find that? Well, that's a full rotation of 360, and then another how many degrees till I get to 421. So 421 minus 360 gives me a reference angle of 61 degrees. And E, a 321 degree angle in standard position, has its terminal arm in quadrant 4. So that's 321 degrees from the positive x-axis in standard position. The reference angle will be from the nearest x-axis, and it'll be an acute angle between 0 and 90. So 360 take away 321, that reference angle is 39 degrees. All right. Okay, our next example, given point P, 3, -4 on the terminal arm of angle theta, find the primary trig ratios. So there's the point 3, -4. It's on the terminal arm of an angle theta in standard position. So if I want, I could make a right angle triangle, look something like this. Then I know that the x coordinate is 3, the y coordinate is -4, right? X is 3, I'm 3 units to here. The y coordinate's -4, that means I'm 4 units down to here. All right, so we've got our triangle made. The question asks us to figure out the other primary trig ratios. So find sine, cosine, and tangent of this angle. Step 1, let's find the length of the hypotenuse. So from this point to the point P, let's find that length. We'll call it R. That's Pythagoras' theorem. Right, so 3 squared add -4 squared, we take the square root. That's going to give us R. So R is going to equal 5. So I can now write my 3 primary trig ratios. If you recall from grade 10, sine is opposite over hypotenuse. Opposite of angle theta is -4. Hypotenuse we just figured out to be 5. So the sine ratio is -4/5. Cosine ratio from angle theta. Here's angle theta. Cosine is adjacent over hypotenuse. So that's going to be 3/5. And from angle theta, tangent is opposite over adjacent. So that's going to be -4/3. Beautiful. All right, so if we look on page 435 in your workbook, let's get that out. Question 10 says, for each angle theta in standard position in quadrant 1, find sine and cosine if you know the tangent in quadrant 1 of angle theta is 3/7. So I made a right angle triangle in quadrant 1. There's my angle theta in standard position in quadrant 1. Tangent is defined as opposite over adjacent. So the tangent of theta was 3/7. I can find the hypotenuse using Pythagoras' theorem. So r squared should equal 3 squared add √7 squared. So r squared is going to equal 9 add 7. R squared is going to equal 16. So r is going to equal ±4. Note that the hypotenuse will always be a positive value. The legs can be negative depending on the direction, but the hypotenuse of these angles will always be a positive value. So r is 4. If I know r is 4, then I know that sine theta will be opposite 3 over hypotenuse 4, and cosine theta will be adjacent √7 over hypotenuse 4. All right, now go to page 454 and read question 13. It'll tell you that alpha is an angle in standard position, so I've drawn alpha. Theta is the reference angle, and we're told the cosine of theta, if I made a right angle triangle, the cosine of theta is 1 adjacent over 4 hypotenuse. Nice. We were asked to find the tangent of angle alpha in standard position, so we know that the negative x-axis, this value actually should be -1. We're going in a negative direction. Remember, the reference angle is between 0 and 90 degrees. So we're going to find this y coordinate, and then we'll be able to figure out the tangent of alpha. So again, Pythagoras' theorem should state that 4 squared equals -1 squared add y squared. So 16 minus 1 should equal y squared. 15 is y squared. Therefore, y should equal ±√15. And again, y is in a negative direction, so y should be -√15. Thus, tangent Therefore, tangent alpha will equal opposite over adjacent, negative root 15 over negative